Welcome back to the Deep Learning series. In the last video, we introduced you to deep learning and neural networks. Now, it's time to dive deeper into how these neural networks are structured. In this video, we'll explore the architecture of neural networks, breaking down the layers that make up these powerful models. Let us understand the basics of neural network architecture. At the heart of every neural network is its structure, often compared to the human brain. Neural networks are made up of neurons, which are organized in layers. These layers are the building blocks of the network. The architecture or design of these layers is crucial to how well the network performs. A neural network typically consists of three main types of layers: input layer, hidden layers, and output layer. Let's take a closer look at each of these layers. The input layer is where the data enters the neural network. This layer receives raw data, such as an image, sentence, or time series sequence, and passes it to the next layer for processing. It's the starting point for all the information the neural network will learn from. For instance, if working with an image, the input layer consists of pixel values. Each pixel's value is passed as input, and each neuron in the input layer corresponds to a pixel in the image. Hidden layers are where the computations happen. These layers process the data received from the input layer using weights, biases, and activation functions. Each neuron in the hidden layer performs a mathematical operation on the incoming data, involving multiplying the input by a weight, adding a bias, and applying an activation function. The result is passed on to the next layer. A deep neural network can have multiple hidden layers. This is why it's called deep learning. The more layers a network has, the more complex patterns it can learn, making deep learning effective for tasks like image recognition, speech processing, and language translation. The output layer produces the network's final prediction or result. It takes the processed information from the hidden layers and transforms it into something meaningful. For instance, in a classification task, the output layer might have neurons corresponding to different classes. If classifying an image of a cat or a dog, the output layer produces values representing the likelihood of the image being a cat or a dog. Activation functions. Activation functions are key to neural networks. Without them, a neural network would only perform linear transformations, limiting its ability to learn complex patterns. Activation functions introduce non-linearity, allowing the network to learn intricate relationships in the data. Common activation functions include sigmoid, used in binary classification, squashes the output between 0 and 1. tanh, similar to sigmoid, but ranges from -1 to 1. Rectified linear unit, outputs 0 for negative values and the input itself for positive values, helping prevent the vanishing gradient problem. Now, let us understand the role of weights and biases. Each connection between neurons has a weight, determining the strength of the connection. The bias is an additional parameter that helps the network make better predictions. Weights and biases are adjusted during training to minimize errors. How does the network learn? The network learns by adjusting weights and biases through backpropagation, which minimizes the error by propagating it backward through the layers and adjusting weights accordingly. This process continues during training, improving predictions over time. In this video, we've covered the architecture of neural networks, from the input layer to the output layer, along with the crucial role of hidden layers and activation functions. In the next video, we'll explore how neural networks are trained, including optimization algorithms and techniques to avoid overfitting and underfitting. Thank you for watching. If you found this video helpful, don't forget to like, share, and subscribe for more insights into cutting-edge development tools. Meta Design Solutions is here to help. Reach out to us at this email ID. See you in the next video.